Okay, so today we are talking about secants, tangents, and angle measures. Um, Yesterday or Monday we just talked about tangents. Okay, so we're going to expand this a little bit. Now remember, tangents is a line that just intersects a circle in one point. It kind of just grazes by the side of it and touches it in one point. A secant line is one that intersects the circle in exactly 2 points. So it actually goes all the way through the circle and intersects the circle itself in 2 different points. Okay, so this line N is a secant line. And we have three basic scenarios that we're going to talk about today. We're talking about the angles created by secants and tangents. And the three different scenarios is when we have two secants that intersect inside the circle, a secant and a tangent that intersect on the circle, and then a secant and a tangent, or two tangents, or two secants that intersect outside the circle. So we have three different scenarios that you need to be familiar with. And the first one is when we have two secants or chords that intersect in the interior of the circle. Okay? As you can see, we've got those two secants that are intersecting inside the circle. Now, this is not necessarily the center of the circle. These are not diameters, okay? They're just two lines that intersect the circle. 1 and 2 are not central angles, okay? And so what happens when you have these two secants that intersect inside the circle, the angle formed is half the sum of its arc and the arc of its vertical angle. So the measure of that angle 2 is 1/2 the sum of its arc, which is BD, and the arc of its vertical angle, which is AC. So if this was 20 and this was, let's say this is 40. If this is 20 and this is 40, what's the measure of angle 2 going to be? Well, you add these together, it's 60, but the angle is half of that sum. So that angle 2 is going to be what? 30. Okay? And then if they ask for angle 1, you could find it, because angle 1 and angle 2 they're supplementary. They're a linear pair, right? Okay? All right. So if we wanted angle 1, let's say they asked for that one, if you knew angle 2, you could find angle 1, but angle 1 has the same relationship as angle 2. It is also half the sum of its arc and the arc of its vertical angle. It just depends on, which one they're asking you for. So it would be half the sum of arc AD plus the measure of arc BC. But like I said, if you knew one, you could find the other. All right, so let's do an example here. It wants us to find the measure of angle 2 if the measure of arc BC is 30 and the measure of arc AD is 20. Okay, so what might we find first here? Angle 1, okay, so to find the measure of angle 1, it is half the sum of its arc and the arc of its vertical angle. What's its arc? 30, and the arc of its vertical angle is 20. Okay, so you add those together and then you take half. So half of 50 makes the measure of angle 1 25. Okay, and so if the measure of angle 1 is 25, what am I going to do to find the measure of angle 2? Okay, they're supplementary because they're a linear pair. So 180 minus 25 would be what, 155? Now another thing that you could do here is, since we know that these two are 50 together, the rest of the circle, which would be these two arcs, would be 360 minus that, which is 310. And you could just take half that to get angle 1. You could do that too. Does everybody see what I'm saying when I say that? To get angle 1, we add these together and divide it by 2 to get this. Well, to get this one, if we didn't want to go that route, you could look at, since this is 50 degrees right here with the 20 and the 30, the sum of these two is the rest of the circle, which is 360 minus 50. Okay? Which is 310, and then if I took half of that, I'd get 155. If that's too confusing, you can just do it the other way. But some people like to do it that way, so I wanted to check that out. All right. So here's another example. Again, we have two secants that intersect inside the circle, okay? And we want to find the value of x. Now, in this case, the angle is not the unknown, but the process is still the same. I know that this angle right here is 110, correct? This is its arc, and this is the arc of its vertical angle. We still follow the same steps. Your angle is half the sum of its arc and the arc of its vertical angle. So I set it up the same way, I just have a different piece of the puzzle that's unknown. Okay? So my angle is 110, and it's going to be half the sum of its arc, which is x, and the arc of its vertical angle, which is 97. Everybody see how I set that up? Okay? Alright, so then to solve for x, I can either distribute the 1/2 or I can multiply both sides by 2. I'm going to multiply both sides by 2. Okay, and then subtract 97 from both sides. And 220 minus 97 is 123. So that x is 123 degrees. Everybody see how I set that up? Okay, two secants that intersect in the interior. The angle is half the sum of its arc and the arc of its vertical angle. Now, my second scenario is when I have a secant and a tangent that intersect at the point of tangency, which is on the circle. So I have the secant and the tangent that intersect on the circle. Okay? And the rule for that is that the angle is half the arc. Okay, that angle there that's created by the secant and the tangent is half of the arc that's made by those. So the measure of angle CBD equals 1/2 the measure of arc CED. So if this arc was, 200, what would that angle be? If that big arc there was 200, what would that angle be? 100, okay? All right, so let's work a couple of problems. In this case, we want to find the measure of angle ABC, which is this little angle right here. Now, I give you arc AB, but this angle is half of arc ADB. Can I find arc ADB? What am I going to do? Okay, I'm going to do 360 minus 102. Okay, and that gives me, what, 258? Is that right? And so then that angle is going to be half of that, correct? So I'm going to take 258 and I'm going to divide it by 2. Okay, if I take 258 and divide it by 2, I get 129. Okay, in this problem, I want the measure of arc DEF. I want this right here. Again, I've got a tangent and a secant that intersect at the point of tangency on the circle, and I'm giving you this angle. What can I get knowing this angle? I can get arc FD, right? What am I going to do? Multiply it by 2. So I'm going to do 2 times 64, which is what? 128, right? But I want this arc. So what am I going to do to get the other arc? Okay, it's the rest of the circle, so I'm going to subtract 360 minus 128. What is that, 232? Is that what you guys got? No. So the measure of arc DEF is 232 degrees. Okay, so that's our second scenario. You have a secant and a tangent that intersect on this circle, and the angle is half the arc. One thing that I remember here is, remember in our circle we have inscribed angles, and it has its vertex on the circle, and it's half the arc too, right? So it kind of has the same relationship, okay, as the inscribed angle does, even though it's not an inscribed angle. Okay, now here is my third scenario. My third scenario is if I have a secant and a tangent, two secants, or two tangents that intersect outside the circle, in the exterior. Okay, and so what you do there is the angle is half the difference of the arcs, the outside arc minus the inside arc. So the measure of angle A here is going to be half the difference of the outside arc minus the inside arc. So the measure of angle A is going to be half the measure of arc DE minus the measure of arc BC. So it's outside minus inside. Same thing's going to be true here. The measure of angle A, this angle is going to be half of the outside minus the inside. Okay, so 1/2 the measure of arc DC minus the measure of arc BC. Same scenario here. If it's two tangents, the measure of angle A is going to be half the difference of this big outside arc, BDC, minus the inside arc, which is BC. Now the thing about this is that these two arcs together represent the whole circle. So you could let this one be x, and this is the rest of the circle, which is 360 minus x. Okay? And we're going to do a problem like that here in just a second. So when they intersect in the exterior, it's half the difference of the arc, and it's always the outside minus the inside. Okay? All right. So here we've got two secants that intersect out here. And so to find x, what are we going to do? Okay, we're going to subtract and take half, right? So we're going to do half of 120 minus 50. Okay, and so that half of 70 is what? 35 degrees, right? Okay. I think some of you guys are sleeping on me today, huh? Are you awake? All right. Now here's one like I talked about a while ago. This time I give you the angle and I ask for the arc. Okay, but it's still the same idea. The angle is half the difference of the outside arc minus the inside arc. Now I'm looking for the inside arc. What do I use to represent the outside arc? 360 minus x. Okay, so this time I know the angle, which is 21, and it is half the difference of the outside arc minus the inside arc. Now notice I've got two x's there, but there's an x for the inside arc and then there's an x associated with the outside arc, so I've got to have both of them. Okay, so again I'm going to multiply both sides by 2. That's going to give me 42, and then this ends up being 360 minus 2x. I'm going to subtract 360 from both sides. That gives me negative 318 equals negative 2x. And I'm going to divide both sides by negative 2, and I get 159. 159 degrees there. Now, I want to show you one possible scenario here. Let's say that instead of asking for the inside arc, they asked for the outside arc. Okay? What would you represent the inside arc with? 360 minus x, right? Okay, you would do the same thing. Now, the reason I'm showing you this is because you got to be careful. When you go to set this up, it's still 21, and it's half the difference of the outside arc minus the inside arc. My outside arc is x, but my inside arc is a quantity. And so I have to put it in parentheses. And the reason I have to do that is because I'm going to have to distribute the negative. And so, you know, this would be x minus 360 plus x. If I didn't do that, my x's would cancel out. I wouldn't have an x to solve for. Okay, so you got to be careful with your algebra there. All right. So when the unknown is the outside and this is a quantity, you have to distribute a negative. Okay. All right. Last one. This one is a secant and a tangent. Okay. And notice, what is this right here? It's a diameter, so keep that in mind. Okay. So we want to find x. They give us the angle. They give us information about the inside arc. What's the outside arc? 180, because this is a diameter. Okay? So I take my angle, which is 45, and it is half the difference of the outside arc minus the inside arc. Okay? So we multiply both sides by 2. Okay, subtract 180 from both sides. That gives me negative 90 equals negative 10x. Divide both sides by negative 10, and so x is going to be 9. Okay, so 3 scenarios that we talked about, okay? If you've got 2 secants that intersect in the interior, the angle is half the sum of the arcs, okay? If you have a secant and a tangent that intersect on the circle, the angle is half the arc. And if they intersect outside, no matter what the scenario is, if they intersect outside the circle, it's half the difference of the arcs, okay? So inside the circle, half the sum. On the circle, half the arc. Outside the circle, half the difference. Okay? 3 basic things that you got to remember. Okay? All right. Your assignment is on the board.